Okay, good morning, guys. So today we're moving on and doing the next section. It's very much about factoring again, but when we talked about factoring before, mostly concentrated on things that were squares. And today we'll talk more about common formulas that might come up with cubes and other simple tricks and things you might want to try when attempting to factor a polynomial before you go the long way, which I'll teach you in subsequent lessons. Okay, number 1, 2, and 3 today in the norm is just solving these polynomial equations by graphing. So I'm not going to do them. You can do them. I'm assuming you kind of did. I saw people working on it already, which is great. So what's the strategy again? No matter what you do, you set equal to 0, right? Graph it and see where it crosses. Anybody get anything for number 1 today? I could believe up to. Okay, negative 1.06. Write that down. There's one answer. Now, that's either all of them or there's 2 more. Anybody? Is that all of them or that's it? Okay. So there you go. X equals negative 1.06, and you are done with that. Great. Sounds wonderful. And of course, take a minute and try number 2. I know it takes time to write it in and type it. On number 2, I think probably you just subtract the x squared, right? Which the other side probably be the fastest way to get equals 0. If you're really paranoid, you don't even have to combine like terms. Like there's a 3x squared on the right, and you're subtracting x squared. That's just a 2x squared. So you can't combine like terms. So if you just want to write 3x squared minus x squared, that would work too. This one's a 4th degree problem, so I could think there might be up to 4 answers to this. I don't know. I have not graphed it, and you're my first hour, so I really have no idea what the answer is going to be. Is it possible to have no answers? Heck yeah, it is. It's possible also for the thing not to cross the axis at all. I'm graphing number 2 on my computer. I'm seeing 2 answers. Are there 2 answers? Kind of like almost like a parabola, right? Like a U-ish thing. Great. And anybody got them yet? Negative 1.16. That I heard right? Okay, negative 1.16 sounds good to me. And I bet you then the other one's positive 1.16. I can kind of tell that. This does have some symmetry to it. It's even, if you remember what that means. It means it's the same on the left and the right. And if you look at the exponents, they're all even. So I could tell that it was being the same thing on the left and the right. So if you say it was negative 1.16 on the left, I know it's positive 1.16 on the right. Good job. And then lastly, just one more, number 3. So 2x to the 5th minus x squared, and then probably just add the 4 over and make it plus 4. This has a 5th power in it, so it's a 5th degree, so it might cross as many as 5 times. I don't know. But as I graph it, how many times do you see it cross? I don't see 5. I just see 1, right? And what is it, like about negative 1 or so, something like that? Not close to it, but I know it's not negative 1. Anybody got the real value? Negative 1.07, pretty close to negative 1. So there's your answer, x equals negative 1.7. Very good, guys. Nice and quick. And that was all you had to do yesterday. So that was hopefully a pretty easy assignment for you. And now I'll kind of make things a little worse today. LGs, here you go. Students will learn about quadratic forms and how to solve polynomial equations by some factoring techniques. There's basically like 5 or 6 tricks that you might try to make factoring something higher than a quadratic, like a cubic or 4th degree or 5th degree. There's some tricks you could try to do to factor them. And that's what we're talking about today, some tricks. The tricks don't always work. And there's only one other strategy to factor something if the tricks fall apart. We'll talk about that another day. But hopefully today we can find some kind of things that might help us along the way.
Like calculator get out of hostage situation now. Thank you.
All right, so we go to the next one, 5.2. that means you got homework, of course. And back to the normal pacing. So tomorrow you'll have all the time to work. In fact, you'll have all weekend to work also because it's not due until Tuesday. Got a 3-day weekend also. So you got a long time till this one's due. Due Tuesday. Write down what it is though. 3 through 12. Just do multiples of 3. So 3, 6, 9, 12. And 20 through 65, multiples of 5. Not a ton of problems there, but they do take a little bit of time and thought, and you're new at it, so that's one. There's not that many. Still encourage you to try to do things on paper. I think it's easier for you. I think you can get more points that way. I think it's better. It's more like the test. But again, you do you. All right, here is the topic for today. Titles, section 5.2, solving polynomial equations algebraically. So the first section was graphically, which is not what we're going to rely on most of the time. And now, of course, today is algebraically. Here we go. Let's see, right off the bat. I would like you to write down the term a prime polynomial right there. See that term in bold, prime polynomial. And it's a polynomial basically that you can't factor anymore. So if somebody says, if you're a prime number, when they say prime number, they mean a number that can't be broken down into smaller pieces anymore, like a 2. Can't write that as anything. 3, can't write that as anything. 4 is not prime because you can write that as a 2 times a 2. Same thing here. A prime polynomial is one that you cannot break down into other factors, something you can't factor essentially. And once in a while, yes, there will be problems on your homework where you look at it and you look at all the tricks we have today and you try to factor it and you say, well, none of these tricks work and I don't know how to do it. And if that's the case, it might be a prime polynomial that you just cannot factor down anymore. Those do exist. So just know that term. And down there's a couple cute little formulas. We've talked about them before. You might want to jot them down again. I don't know. Probably, you don't even need to really. Oh, wait. Oh, those are new ones. Write those down for sure. Oh, gosh. I thought this had some of squares and it's cubes. Oh, we got cubes are brand new to us. Write those down at the bottom. So we can do anything with quadratics. You have a squared thing. You can always go to quadratic form. You can always get the answers out. That's cool. The next degree up is a cube, and we only got a few tricks for cubes. After that, there's actually no tricks after that at all. 4th degrees, 5th degrees, 6th degrees, there's no tricks. But there's a lot of tricks for cubes. First one's called a sum of 2 cubes, if you see it right there. And if you can recognize that the thing you're working with is something cubed to the 3rd power plus something else cubed to the 3rd power, then that first formula you can use to factor things down a little bit. Likewise, if you see something cubed minus something else cubed, then there's a formula to factor that as well. The names of them are pretty obvious because sum means to add. Difference means to subtract. Cute little formulas, okay? Write them down, look at them. We'll look at those in just a second. You guys done writing them? Need another minute? I'll give you just a couple seconds. All right, I guess to summarize, here's everything you need for the day. We're gonna just take a minute and write down the following tricks. I don't know if you want to write them all down. The first one is just saying the normal thing I always harp on with factoring. That's the first thing you should check. Do they have something in common? And can you factor that out? So if you forgot to check that all the time, you might want to write that down real quick. Okay, but check that they have something in common. A greatest common factor if you want to math it all up. So look at the case they got right there. They got a 2a to the 4th b cubed plus a 6ab. If you look what they have in common, they both have a 2 that goes into them. They both have an a that goes into them. They have a b that goes into them. So you could factor that out of the entire expression and get the remainder stuff to be down a little bit. So that's the first one. And that's what you should always check for any factoring. I don't care what we're studying, cubes or quadratics or linears or anything. You just factor out things that they have in common. The one after that's called difference of two squares. You don't have to have that one. It's just, it comes up a lot. But really, it's just factoring like you've already done factoring. Like, okay, if for a quadratic, an x squared thing, could you find two numbers that multiply to be the last term? Could you find the two numbers that add to be the middle term? So you don't have to have difference of two squares. The other two we just talked about, sum of two cubes and difference of two cubes. One after that is called a perfect square trinomial. And again, anything in this table actually that was just x squared or squared things, no cubes, just squares, you really shouldn't need anything new for. You're just going to fall back on your old techniques of I'll find two numbers and multiply the last term and add to be the middle term, and I'll play with it and I'll factor it kind of stuff. So with the case of the perfect square trinomial, that's a really weird looking formula. You might want to write it down as a reference, but I think in practice, you won't sit there and say, oh, that's a perfect square trinomial. I won't either. You're not going to talk like that. We'll just factor like normal. And same with the general trinomials. When it says general trinomials, is the exact same thing. It's just factoring a quadratic kind of thing. See, it's all squares in that. The one other thing that might come in handy today is the one down at the bottom called grouping. So I'm trying to say, hey, here's the three things on this slide that we really haven't covered. Sum of cubes, difference of cubes, and grouping. So if you had to put stars by some, maybe put them by those. The sum of the cubes, difference of the cubes, and factoring by grouping. That's really all we got when it comes to something that's a cubic, a third degree. There's some other techniques too if you get in a bind, but we'll save those for another day because those techniques will be the same ones you'd use for a fourth degree or fifth degree or sixth degree, whatever. So that's pretty much it for notes. I mean, we'll do a lot of examples. We need to see what the heck this stuff is talking about, but as far as just writing down pure information, I think that's all for today. Man, they just throw them right into the fire, don't they? All right, the first example coming up on the next slide, example 1, looks like something like this. And like, well, what the heck is this? It looks like it's got a 12th in it. I thought we weren't talking about 12s today. We're not really talking about 12 powers today. We're talking about just cubes and low. Now, the only thing I've been talking about today are these three things, factoring by grouping. By the way, the grouping one always has to have 4 terms in it. This is not 4, this has 2. I'm thinking maybe this is a sum of cubes, maybe. Now, this thing's obviously a cube. Would you agree? This thing doesn't look like a cube, does it? So we're going to massage this a little bit. Now, here's the hard part, okay? When you do this formula, you have to write this thing, first off, as one thing, just one kind of thing cubed, plus some other thing cubed. That's the first thing you need to do. I need to write something cubed plus something else cubed, just one thing. So we're kind of undoing what we did with the binomial theorem the other day. Can you think of a number that cubed is x cubed? Well, I would think it would be x. Would you agree? X cubed is x cubed, right? But you got to take care of the numbers too. There is a number that times itself 3 times as 8. Anybody know what it is? Sometimes it's all 3 times. We might need a little table again, might we? All right. Might want to jot this thing down. So before, I have for simplifying roots, I told you all the common squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. Also, also very good for this, specifically for today, because you're doing cubes and stuff like that, maybe to know some common cubes when you cube something. 1 cubed, 1 times itself 3 times is 1. 2 cubed is 8. 3 cubed is 27. This one's 64, 125, 216. You'll never need that one. It's okay. 7s, you probably won't ever go that low. But those are perfect cubes. And if you look at the perfect cubes, well, now do you see a perfect cube? I do. What cubed is 8? 2 cubed is 8. So you can think of this thing as just the quantity 2x cubed. And kind of undo it real quick, just like yesterday with the binomial stuff. Didn't we do the number part separately? 2 cubed and then x cubed is the same thing, right? 2 cubed is 8, x cubed is x cubed. So that's still 8x cubed. Cool? Now the 125. Hey, what a coincidence. Look at the list of cubes. What cubed is 125? 5 cubed is 125. So for the 125, I'm going to put a 5 for the 125, because 5 raised to the 3rd power is 125. And there is, why does something raised to something else is in fact 12? It turns out to be 4. Do you remember that exponent rule? When you have a power raised to another power, you multiply them? Okay, that's coming up here. So I had to think to myself, okay, well, something raised to another power must be 12. If that power is 3, it must be 4. So that's kind of how you think that real quick. Any questions on how we thought that through? Because that's kind of the tricky part right there. 2 cubed is 8, x cubed is x cubed, 5 cubed is 125, and y to the 4th times itself 3 times y to the 4th times y to the 4th times y to the 4th is y to the 12th. So we've written it as 2 different cubes. Something cubed plus something cubed. And now all I got to do is match the formula. This is a sum of cubes. Here's my formula for sum of cubes. What's A and what's B? This is A, would you agree? And this is B. So all I got to do is write out this new formula and replace the A's with 2 x's and the B's with 5y to the 4th. So here we go. A, which is 2x, plus B, which is 5y to the 4th. So we kind of broke that down. And then inside of here, we have a squared. So I got to square this thing. What's 2x to the 2nd power? Well, 2 to the 2nd is 4, would you agree? And x to the 2nd is x to the 2nd. So there's a squared, 4x squared. Then you got a minus sign, so minus. And then after that comes a times b. Well, that's 2x times 5y to the 4th. 2 times 5 is 10. And then you have an x and a y to the 4th. And then lastly, on the end, you have plus b squared. So I have to add on whatever this squared is. If this is raised to the 2nd power, well, 5 to the 2nd is 25, right? Anybody know what y to the 4th to the 2nd is? Power. No. What do you do? What do you do when you have a power raised to a power? Yeah. So if it's y to the 4th squared, it'd be y to the 8th, because 4 times 2 is 8. And that's pretty much all your task is to recognize that. There's nothing else you can do here. I mean, can you really, do these guys have anything in common here? Can you fact, no. Is it a difference of cubes? I don't see any cubes. Do you see any cubes? I don't see any cubes. Same thing here. This is like a gross mess. So pretty much once you recognize it and use the formula one time, you're done. Okay, difference of cubes, sum of cubes, that's it. And that's all you gotta do. Let's try it again. Can't have enough of these kind of examples. That was example 1A. Now we're gonna do example 1B. All right, 1B says that this one is 54 x to the 5th minus 128 x squared y to the 3rd. That's our next example. That would be on the slides. Okay, so again, you got to look at it. And what techniques do we have? 54 is 128. Are those any cubes? I don't think they are they? But never forget the most basic thing. Do they have something in common? Do you see any numbers or variables that everybody has in common? I do. What goes in 54 and 128? There's at least one number. 2. Okay, we can factor 2 out, right? Let's do that. We'll factor 2 out. Any letters they have in common? They both got an x squared in them. Would you agree? They both got 2 x's. So I can factor a 2 and an x squared out, and we'll see what's remaining after that's done. If the 2 wasn't enough, if there's still something they have in common, we can take it out again. We can do this as many times as we need to if need be. All right, this one right here, 54. Well, if you took a 2 out of 54, you're dividing 54 by 2, which turned out to be 27. And you took 2 x's out. There were 5, right? So there are 3 left. So what's left inside of this after that is a 27x to the third. The other person, well, it was a minus, so it's still a minus. You took a 2 out of a 128, and I'll tell you what 128 divided by 2 is. It's 64. You took the x squared out, right? So that's gone. And what's still remaining is this y cubed. So this is the same thing, just in a different form, starting to get factored down a little bit. Can you do better? Always ask yourself, can you do better? The answer is yes. If you look at the first one, look at this thing. It's got 27 and a 64. Not a coincidence. It's like it's designed to work out for you or something like that. 27 is a perfect cube, right? And 64 is also a perfect cube. And clearly x cubed is something cubed and y cubed is something cubed. So this is a difference of cubes. So I can factor this down as well. So we're going to keep going. First off, inside of this world, I got to think of this as something cubed minus something else cubed. I have to identify first one quantity that is cubed to make the first thing. Well, what cubed is 27? If you go look at your perfect cubes, what number cubed is 27? It's 3, right? So 3 goes here. And clearly, x would be what needs to be cubed to get x cubed, right? And same logic on the 64. Look at the 64. You go down your cube. 64 is 4 cubed. So I can write 64 as a 4. And what cubed is y cubed? Clearly y. So 4y cubed like that. See the structure of that? See how you got to write as one thing first? If you don't do that, the whole formula is not going to work because it's all based on what this thing is and what this thing is. In our case, a is 3x, correct? B is 4y, right? And this is a difference of squares, so I'm going to use this formula on this part. Of course, the 2x squared is still there. It doesn't disappear. I'm not really doing anything with it. It's just hanging out. But this entire part, the difference of squares right there, we're going to rewrite it as, with our formula, a minus b, which is 3x minus 4y, times this thing, which does take a little bit of cleaning up. So inside of here, I got a squared. Well, a is 3x, right? What's 3x squared? Well, 3 squared is 9, and x squared is x squared. So there's the a squared part. This formula has a plus in it, so plus. And then it's got a times b. So 3x times 4y, 3 times 4 is 12. And you got an x and you got a y, so 12xy. And the very last thing at the end, plus b squared. Well, what was b? It was 4y. And 4y raised to the second power, 4 squared is 16. And the y squared is obviously y squared. And again, like I just got done saying, once you've done the difference of cubes or sum of cubes, you're done. There's no more factoring you can do, I promise you. So this is done, and there's nothing else I can do with this. So we factor down as much as humanly possible. Getting the gist of the cube thing, kind of, a little bit. Well, let's see here. Let's try another type of thing. They're not all going to be perfect cubes. Differences of cubes and sums of cubes. Right down this bottom one, example 2. This one looks like a different breed. It's got a lot of stuff in it. A lot of stuff. What the heck? What in God's name is going on with this thing? I don't know either. I haven't looked at it yet. Yuck. problems are they giving you guys? Seriously? This is mean. Wow. Wow. Whew. Look at that thing. That's horrible. The only other strategy is three strategies today. Sum of cubes, difference of cubes, which are pretty obvious. They got two things, right? Something plus something or something minus something. This is a whole other beast. The only other technique you have is, say, factor by grouping. That's the only other prayer, and I'm not even sure that's going to work on this one because it says it could be prime. By factoring by grouping, what you're trying to do is in groups, see if they have something that they have in common. What do we got? What kind of letters are involved in here? You got X's and Y's, right? What other kind of letters? A's, B's, and C's. Would we agree with all that? Okay. It might be a good idea to lump things that are X's together and things that are Y's together. Now, I honestly don't know how this is going to turn out. Every time I get up here, I know exactly what's going to happen at the end. This time, I do not. We're going to just see. So first thing I'm going to do is just get things with X's kind of together. This was an X thing. No X's, no X's. Here's an X thing. 28bx squared. Any other X things? That's an X thing. Minus 35 cx squared. So there's all my X things together. I'm going to attempt to look at things that kind of have something in common as a group. I'm going to try to factor this group. But let's not get ahead of ourselves. There's still some Y stuff too. So I'm going to make another group for the Y stuff. Let's see what kind of Y stuff I have floating around. I got a -16. Well, I'm going to go in alphabetical order. This goes A, B, C. Would you agree? I'm going to go in alphabetical order. This has an A. So how about -8 AY? Dealt with all the X's. Y's, let's see. There's a -16 BY. And there's also a +20 CY. So by factoring by grouping, what you're trying to do is make groups that kind of are related somehow. It does take some guessing and checking, and it doesn't always work. I'm not sure if this is going to work or not this time. All right, so I got a group of X stuff and a group of Y stuff. What you're doing by factoring by grouping is you're trying to factor each group separately and hope they have something in common. So if we look at this first group, just factor this by itself. Do you see any numbers that go into 14, 28, and 35? 7, right? So you could factor a 7 out of this group. Are there any letters that they all have in common? They all got X squareds, yeah. So let's take a 7 and an X squared out of this group, and then we'll cross our fingers and see what's remaining. Here we go. If you take a 7 and an X squared out of a 14ax squared, there'd be a 2a left. If you take a 7x squared out of a 28b, there'd be a 4b left. And if you take a 7 out of a 35, there'd be a 5 left. And since you took the x squared out, it's just going to be a -5c. Now over here, let's do the same kind of logic. Let's see if there's anything that they have in common. Are there any numbers that go into 8, 16, and 20? 4, can you go higher? Well, no, I guess you can't, can you? No, I'm an idiot. So 4, I agree with that, 4. Any letters that they all have in common? They all got Y, don't they? So let's take out a 4 and a Y, and we will see what's left over here. So when we do, there'd be a -2a. The next one would be a -4b. And the last one would be a +5c. And now that I've actually done the problem, I see what they were going for here. Do you see that they almost have something in common? Like this group and this group are almost having the same kind of thing here. What's the difference between this and this? All the signs, right? Your job, if you're trying to factor by grouping, is to get them, after you factor them, maybe they have something in common. What could I do to force this and this to be the same? Well, they have the wrong signs, right? So why don't I just factor a negative out of this? I'm going to factor a negative out, which changes all these signs, and that would be a +2a, a +4b, and a -5c. But there's no thing I can tell you. It's like, oh, factor by grouping, always do this. Basically, what you try to do is lump things into two different groups, factor those groups separately, and hopefully they have something in common. Because just like any other factoring, if this thing is here and this thing is here, then I can factor it out of both of them. So factor out this 2a plus 4b minus 5c. That was in both the things I'm working with. It's in this thing and that thing, so I'm going to factor it out. And when you factor it out of both of them, the first one, you're left with a 7x squared. Because you just took this out, right? Because you factored this out. And then minus a 4y, and that's it, because you factored that out as well. So that was a weird way to factor. Very weird way to factor. And I expect to be, that's kind of something you fall back on if you're desperate. Like if I'm really desperate, I don't have any techniques at all to factor something, I might want to lump them into groups. How did I decide what groups to make? Well, you look at things that are in common. So this had x squareds, and this had x squareds, and this had x squareds, right? And this had a y, and this had a y, and this had a y. I know there's a bunch of other letters floating around, right? But the fact that these three, all the x ones, all had something in common, kind of said to myself, maybe I should make a group of x's. And the fact that all the y's had just a y, maybe I can make a group of those. And then factor them individually, try to get them to have the exact same thing in them, and then factor that thing out. That's factoring by grouping. That's a hard technique. That was a pain in the butt, that problem. I did not like that one. All right, let's try one a little simpler then. Keep practicing. Can't practice this crap enough. Here we go. Write down example 3. 64. We're back to just cubes. That's a short thing, right? The shorter it is, probably the better it's going to be. I hope. Now, especially today, when you see just two things, I don't care what powers they're raised to, you should probably think it's either a sum of cubes or a difference of cubes. And even though these are raised to the 6th power, that's exactly what they are. So here we go. 64 x to the 6th minus y to the 6th. Can I force this somehow, some way, to be a difference of two things cubed? The answer is yes, I can. First off, there is a number that when cubed is 64. You'll see the same numbers popping around in your homework all the time. They're going to keep using 8s and 27s and 64s and 125s. They're going to keep using these perfect cubes. And you see 64, you should think, okay, 64 is 4 cubed. I'm trying to write this as a cube. I'm trying to write this as a perfect cube. All right, let's see if you get this one. X raised to what power when cubed gives me x to the 6th? The 2nd, exactly. Yep. Very good. So we're going to start looking at this thing as just the quantity 4x squared cubed. And similarly over here, I have to think of the y to the 6th as something cubed. And by the exact same logic, we could call that y squared. Y squared to the 3rd, that would be, in fact, y to the 6th. And now you've got a difference of cubes. So you go to your difference of cubes equation right here. 4x squared is a, y squared is b, just literally matching things up. And the formula starts off with a minus b. So 4x squared minus y squared. That was a. There's b. And you got this stupid thing here. A squared. Well, that means I got to take this thing and square it. 4 squared is 16. What's x squared squared? X to the 4th. Yeah. So there's the first part of that. There's the a squared. Just literally following the formula. It says plus, all right, plus, and a times b. So plus a times b would just be 4x squared y squared. Nothing really like to combine there. And then lastly, on the end of your formula, you got plus b squared. So plus this thing squared, but y squared squared, remember, multiply the exponents, that'd be y to the 4th right there. Can you do better? Probably not. At least not on this mess. This is gross. You know what? This does go down farther. Did you write down one called difference of squares? I said you didn't really need to, but it does come up. there was one that says something squared minus something else squared is a plus b times a minus b. Now this is 4 something squared. Yeah, that's squared, that's squared. So we can actually go even farther on this. And by the same logic, if I think of this first thing as 2x squared, because 2x times 2x is 4x squared, I can think of the y squared as just y squared. That's the same stuff, I'm not going to rewrite it. Then this is a difference of squares, and I can factor it down farther even from there. So here, a is 2x, and b is y. So the formula says that I can factor this difference of squares down into a plus b times a minus b. So those two can get rewritten like that, which is even better. And over here, a bunch of nonsense happens. We're not going to worry about that junk. Are we feeling okay on the sum of cubes and squares and things like that? Because that's kind of the trickiest one. Let's try another one. Let's do example 4. Write that down. That's got 4 things. That doesn't look like a difference of cubes. That doesn't look like a sum of cubes. So the only other thing to fall back on is factoring by grouping. We're going to try to create 2 groups, factor them separately, and hope they have something in common. That is the strategy. Typically, if it's going to work, if you write it in order, the 2 groups you'll want to have are the first 2 and the last 2. So here we go by factoring by grouping. Again, you just make 2 groups. I'm going to think of this as a group. I'm going to think of that as a group. Okay. All right. Looking at these groups separately, the first group, just factoring the first group. Is there anything they got in common? They both got a 4 goes into them, right? And they both got, everybody's got at least 2 x's, right? So I can factor out a 4 and an x squared from this first group. And that leaves me with, if you take a 4x squared out of a 4x cubed, it'll leave me with an x and plus 3 when you're done with that. Now remember, when you're factoring by grouping, your strategy is I'm trying to get this group here and this group here to have something in common, so I can factor it out. So over here, when I factor this by design, I'd like to have either a 4x squared in it or an x plus 3 in it. I see an x plus 3 buried in this. Do you see an x plus 3 buried? I see it. What can you factor out of both of these? Well, they're both negative, correct? And what number goes into both of them? So if you factor a negative and a 9 out, guess what's going to be left? If you take a negative 9 out of a negative 9x, there's just an x left. And if you take a negative 9 out of a negative 27, there's a positive 3 left. That's great. That's great. It's like the problem was set up to work out or something. Because just like anything else, I know it's more complicated, but they have something in common. They both got an x plus 3, right? Anything they ever have in common, you can just factor out. So we'll factor out the x plus 3. And when you take it out of both of them, it's like gone. If this isn't here anymore and this isn't here anymore, what's it say? It says 4x squared minus 9. So that's what's left. 4x squared minus 9 equals 0. Score. This one has come up enough. I guess maybe we should write it down. I mean, we could just think it through. We could factor this if we really thought about, okay, this times this. This, again, is a difference of squares here. 4 is something squared, correct? 9 is something squared. So if you go to your difference of squares equation, if you can figure out what squared is 4x squared, I strongly encourage you to always just take a stupid second, even if it's really obvious, and write like this. You know, I got something squared minus something else squared, just like the difference of cubes and the sum of cubes and all that jazz. Well, what squared is 4x squared? I think it's 2x. Would you agree with that? 2 squared is 4. X squared is x squared. And obviously, what squared is 9 is 3. So when I'm using my difference of squares equation, this top one here, difference of squares, A will be 2x and B will be 3. So I can literally take this expression right here and use this formula to factor it. It says A plus B, which is 2x plus 3. And then it says a minus b, which is 2x minus 3. And it's factored all the way down. And we are going to want to learn how to factor polynomials as much as humanly possible. So a lot of weird stuff here, and that's kind of all there is to it. Lastly, I want you to do this one right here down here. Solve this, write it down, x to the third plus 4. It's the exact same thing. There's 4 things. And if you factor, you turn them into a group of 2 in the front and a group of 2 in the back. Try to factor something out that they have in common. What could you guys factor out of that first group? I concur. So what you're doing, you should have factored out an x squared. The next thing written would be an x plus 4. Boy, 25 and 100 on the next group. It's pretty obvious what goes in both of those. 25, right? Now, you also kind of want the signs to match up. You know, this is all positive, this is all negatives. You might want to factor out the negative also. So I'm going to factor out a negative 25. If you didn't think to factor the negative out, that's okay. You would see on the next line that these two didn't quite match up. The signs are a little off, so you could factor out for that. But if you take a negative 25 out of this, guess what you're left with? X plus 4. So that usually doesn't happen. It's like a long shot where you factor by grouping that actually works out that they have the same thing in them. But most of the problems on your homework will be designed to do that, so it's going to be okay. And then again, if they have anything in common, you can factor them out. They both have an x plus 4 in common. So if you take the x plus 4s out, take it out, it's right there. Then you got an x squared minus 25. X squared minus 25. X squared is a square, right? Is 25 a square? Yeah, it's something squared. So this is a difference of squares, and I should probably apply that top equation there. So just looking at it structurally, this is the same as x squared minus 5 squared. So a must be x, right? And b must be 5. A is x, b is 5. This one up here. A is x, b is 5. My bad. So right here, the formula says a plus b, x plus 5, times x minus 5. And it's all factored down. Now I'm getting so excited about all the factoring that because sometimes I'm not reading the directions. What do the directions actually say to do on this one? Solve. Well, why am I spending all this time teaching you how to factor anyway? So you can solve equations. Do you remember what you do? If you got it all factored down, it's equal to 0. How do you tell what the answers are? When do the factors themselves equal 0? So this answer would be x equals what? Negative 4. Here's an answer, x equals negative 4. Another answer is x equals negative 5. And the third answer is x equals 5. This is really the speed of a problem that I would expect you to understand how to solve. So complicated ones with x's and y's and all this busy crap going on, I wouldn't get too bogged down on that. Do it on your homework and try your best. It's good for you, but I'm not going to put it on the test. Everything on my test will just have one letter in it. X. Okay, I'm not going to have any x 6 minus y to the 6. I'm not going to try and screw you or anything like that. But that's all we're going to do. That's all the time we got for today. So go ahead and put it away. There is something else I need to tack on tomorrow to finish up this lesson, but I think that's plenty for today. So why don't you go and get started on that homework tonight? Try your best, come with some questions, and tomorrow we'll tack on one more thing that might work in a pinch: quadratic forms. Gotta love that, don't you?
Some of these in here,
Yeah.
I don't have to keep more yet.
Okay, that's fine.
They're
Yeah,
ungraded.
that's okay.
And I have a question on this one. One of them is the pre-calc. They're doing like code. One of the problems having them list like